The original information that we are given is first that we have 10 logs. They're all lashed together. Each has 33 centimeters in diameter, or that would be 16.5 centimeter radius. Each has a length of 6.1 meters, and all the people that are standing on top of it, each person would be 70 kilograms. And the specific gravity of wood, which we'll use to find density, is 0.60. This is our model. It's a makeshift raft. It's made out of coffee stirs and string. Not exactly the best, but it'll have to do. As you can see, put it down here, floats, and essentially what we're going to do, a little person will come down, jump on it, 70 kilograms each. The unknown variable is the person's weight. We will use this as our x variable, and that is what we're essentially solving by finding when the people's feet will be wet, and the specific gravity of wood will give us the density, which is also crucial. Right here is our essential information that we need to know. As you can see, the force of buoyancy minus the force of weight, underlined there, will equal 0 because the object is floating. The force of buoyancy and force of weight both have g in gravity, so those will cancel out. And essentially, what our formula will look like is the force of buoyancy minus the force of weight divided by 70 kilograms equals X amount of people. This is because whatever the force of buoyancy minus the force of weight is, that leftover weight will be taken up by the certain amount of people that will make it so it floats exactly. Thus, whatever we find X to be will essentially be the number of people that make it float, not what will make it sink. Right here we have volume. It's a little out of order, however, still 10 logs times 6.1 meters length times 1.65, which is the radius, meters squared pi, will give us our volume of the raft, which is 5.21 meters cubed. Here, moving along, the specific gravity of wood is 0.6. We know that the density of water is obviously 1,000 kilograms per meters cubed, so thus this would make it 600. And coming down here, what we have is 1,000 water times the density of our raft minus 600 times 5.21, which is also the density of raft, divided by 70. Now we find that our answer is 29.77. I do know that there is a little rounding error, so the actual answer might be closer to 29. However, either way, 29 people is what makes it float. Thus, either way, the amount of people to make it sink or the people's feet getting wet is what the question is asking would have to be greater than 29 people. In conclusion, we manipulated the buoyancy formula, and while doing so, we found out the amount of people that a raft can hold, and by finding out that, we find that our raft can hold no more than 29 people without it sinking at least a little bit.